This is the first Alumni and Mentors Network at Michigan's Robot 3 Days team.
Hello, I'm Alex. I'm a sophomore studying material science and engineering.
I'm Andrew Dickinson. I am a computer science major and I'm a junior.
Hi, I'm Kian. I'm a sophomore studying mechanical engineering.
Hi, I'm Joey. I'm a sophomore studying anthropology and cognitive science.
I'm Jade. I'm a freshman studying math and physics.
Hi, my name's Emily Grimm. I'm a freshman and I'm studying mechanical engineering.
I'm Luke. I'm a sophomore studying mechanical engineering.
I'm Jonathan Lacone. I'm a freshman studying computer engineering.
I'm Travis Garlick. I'm a sophomore studying computer science and engineering.
Hello, I'm Paul Bonin. I'm a senior studying computer science.
Hi, I'm Anurag Bharadwaj. I'm a junior studying computer science.
My name is Colin Bott. I'm a junior studying mechanical engineering at the University of Michigan. I like robots.
We're participating in a competition amongst college students where we design a robot to compete in the first robotics competition in only 3 days. We just got the game reveal same time as all of the other high school students, but we're just going to spend the next 72 hours designing for that challenge. We hope this is going to give some teams out there some advice on kind of how to proceed, maybe some information on the design process we're going through, and hopefully we're going to have fun while doing it. So when you're talking strategy, the first thing is always read the game manual. You cannot do anything before you know the rules. This is all about just what do the rules say? What does your robot have to do? And what restrictions apply?
Suggestion, silently read game manual, then talk about strategy.
Yep.
Yeah?
Okay.
Yes.
Okay.
So does that mean each team places 2, so the alliance places 6?
I think we mentioned that
At the start? Once you know that, you should know the ways you can score points. So that's kind of the next phase we went into, is looking at what does this game entail? What can you do? What does that earn you? And that really opens up the field for what can your robot be designed to do. This is not at all about how does your robot do it. This is all about, if possible, if everything were possible, what could we do?
I was looking at the diagram. Either one cargo or one null hatch panel between
It says pre-populate one in each of their 2. So
No max height past starting configuration except for the hatch zone.
35.
okay. Also, do we have like a meter stick, a yard stick even?
That one's at 5.75. Yeah?
Yeah.
So 19.75. Actually, the centers for the hatch are about where the lower lip for the...
Yeah, actually. The center of the lowest cutout is 1 foot 7 inches from the carpet.
1 foot 7
Which is going to be 9.5 inches for you.
So
after that point, it comes down to prioritization. The one thing that you have to recognize is you cannot do everything. Especially for us working in a competition where we've got 3 days to design and build the robot. But that applies to teams even with 6 weeks that you've got. You cannot do everything. Basically, we're trying to go through a priorities list and say, for us, a lot of times we're looking at everything we just said, everything is possible, but what should we focus on?
We might establish our robot goals differently based on our team goals.
So then we should come up with team goals first, is what you're saying?
Or at least define them. Because I think we all have an idea of the team goals. We should just... That is a goal we could consider.
yeah,
Write it up there and then
the normal game would be more on the side of helping teams.
Any other goals? Like, have fun.
Yes.
Is it a goal to have a finished robot at the end of this, regardless of whether it wins the competition? Like,
Yes. So, essentially, a team goal is to meet the robot goals.
yeah.
Or meet as many as we can.
So build our plan.
Yes.
Whatever we plan to do,
Yeah.
we want to do it.
Yeah.
Right.
Challenge ourselves. We need to start thinking about ranking them.
Yep. Does anyone disagree with these? That's fine. We are a monolith. Robot goals.
Okay.
So this is going to be.
Yeah. What kinds of things are these?
Drive.
Hey.
Good one.
Is that number 1 somewhere?
Ron, that's
You
not
can't
number
put
1.
above
that's
that.
number 0.
1. Pass.
Oh, inspection. Yeah.
Rules.
2.
Drive.
I think, yeah, we...
Alright. Anything else we can do in this game?
Defend.
Good, thank you. Then you get to things. Do we want to score high goal, low goal? Do we want to score, in this case, hatch panels or cargo? And so that then is kind of a decision. How many points do we get? 3 points versus 2. Maybe how much more time does it take to score in the high goal versus the low goal? How are we going to maximize our score? For us, we actually prioritize going to the lower scoring areas because in our opinions, we don't really think that those lower goals are going to fill up, at least at our level of play. When we started brainstorming for our designs, we all went out with this list of priorities and we said we need to come back with a design that accomplishes A, B, and C. And we broke into smaller teams for this, and this is actually a great activity for some of the teams who are larger than ours. A lot of first teams out there are going to have a lot of members, and this is a way to get a lot of people engaged and get a lot of ideas going really quickly.
Comes down.
Okay, so we've got
stick it,
all
comes
these
up,
things, and we've
pulls
been
the thing
talking
off,
about
goes
elevators.
up to the thing, comes down.
Speaking of elevators,
you might need something in the back to push it.
Yeah. This is like pretty straightforward. We're going to pick up and release at the same height, so it's just got to be like an opening and closing mechanism.
Oh, okay.
What about rollers?
It's kind of.
We have 3 green compliant.
Okay, so ball ideas.
So 3. We have 3
Just
rollers.
stuff just
3 rollers.
Okay.
That's
intake
it.
wheels.
In terms of...
Some kind of like.
And then once we've got those ideas, we then as a group decide which are we actually going to go with. The most important thing is that we get everyone on the same page here because we can't have a split team going forward. So everyone agrees on a design and we say we think this is best. Maybe there's some drawbacks, but everyone recognizes that this is the plan moving forward.
Can you draw the hook kind of much larger?
It's a zoomed in version, yeah.
Okay, so
there you go.
we have like a hook right here.
So this is an idea for climbing. It's just a wheel on a stick that can rotate.
So one way to collect and deal with the panels would be kind of an arm that sticks off and just rotates, and it could be shaped like this.
You've got a central. You've got a shaft.
Yes.
Yeah. Like a motor with a shaft, and then the shaft has like an offset key.
Oh, and you spin the shaft.
And if you basically just put like a platform on top of your robot that had a slight slope down and dumped balls up there, they could roll down. The issue with this is that there's still going to be a bit of a gap where your bumpers space you off from the rocket. This is kind of what the idea sparked in my head from what. So this bigger disc is the game piece. This is the panel.
I mean, there are always options when it comes to like just making a mess, right?
For example, there's like, I guess, a couple categories of ways to move between picking off the ground, cargo ship, and rocket ship L1. There's like kind of what Luke was talking about, central like pivot type thing, where it pivots about an axis. You could ship that pivot back. That's kind of one. You can have like some sort of belt system where it, raises and lowers a mechanism up and down. That's another. What else?
I mean, you can have a true elevator.
But that's being heavily voted against because elevators are clunky to design and build.
Or just run it back and forth.
The question is, do we have something that goes inside the belts?
To like get it out.
It's literally you want it to like have a hard stop or something. Like it should.
No, I'm saying
like you don't want it to bump into the wall and it doesn't.
Yeah. Or if we're gonna do it with the stealth wheels, we could do it to where there's only a certain length of metal.
Once we completed our initial design work, we moved on to more detailed design using CAD, and we also created some rudimentary prototyping for the rest of the robot.
Trying to get our. Okay, wheels. Let's see the wheel situation.
Oh, never mind. It should.
It's just the arrow indicating the direction.
Okay, this is.
Well, no, I'm going outside.
Wait,
You're going outside.
He's gonna go outside.
Wait.
You guys have like a gun?
What other options to test?
Can you grab another one of those and start stacking stuff on these?
So
we're looking at the wheels and how well it
Well,
comes in contact
You
with
put it on the
the
bottom.
So we're adding
Yeah,
more
you put it on
compression.
the bottom.
Yeah. So it gives it a bit more oomph.
We're trying to
Ah,
figure out
okay.
the compression we need.
Okay.
So should we try to combine both sides?
You wonder why your phone was
It's duct tape, don't worry about it.
Woo! It definitely retains more speed. Although that's not necessarily what we're going for.
Did you just a decent speed out of the shooter?
It's not a shooter.
It is a shooter.
It's a spinner.
Let's not pretend. Pretty far up the ramp too. Whoa! All right. No, but that's. There we go.
It's a shooter.
It's a shooter.
Do it slow.
Oh.
Yeah, this is the, whatchamacallit, I forget the name.
Hatch.
My hatch panel grabber. I could have just read it there. Pretty neat. Rotated, actuated by this servo here. It's going to pivot about this axis so that we can take it outside our frame perimeter after the beginning of the match.
Oh, I'm making a big arm that moves cargo into the goals. So it rotates around here. Sucks in and puts out the balls here.
Oh no, what are you doing, Travis?
Passing time while he rewrites everything from the bottom up.
How's that going?
Slow but sure.
I think we're way behind, and we're never going to get this robot done on time, and we need to work very hard so that we don't fall too far and even more far behind. That being said, we do know a general idea of what we're doing.
And the deadline you had set of midnight for rough CAD sounds like we're a little behind that, right? Not disparagingly, but.
Once we were able to actually complete some more work into CAD, we were able to decide on a size of a chassis, and so we've started building that, and we've gotten pretty far on that as well. Hopefully by tomorrow that'll be done, ready to run.
I don't want to drill a hole in the Rio. That would be tragic.
We have an adapter for this, right?
No.
Did we? I wasn't
For plugging it in or for using it?
The black
All I got was
plastic
the motors.
tub. Okay. How's this going?
Sure. Working on the got ourselves a Rio mounted to a plate, and then we're going to put it on these churros over here. And it's gonna be good.
Really don't want to wash gears.
True.
Okay.
True.
Okay, so jelly it is.
We're gonna have to push hard for the CAD in the morning, and then we're just gonna have to make parts all of tomorrow afternoon, and then that leaves what, I don't know. When are we done here? What is it? Today's Saturday.
This is gonna be one jank robot.